Researchers have discovered that the dwarf planet Ceres is an ocean world with salty water underneath its surface. Ceres is a dwarf planet and it is the largest known object in the asteroid belt between Mars and Jupiter. Based on recent NASA findings, it has shown that Ceres may be an ocean world with intriguing geologic activity taking place on and just below its surface. Global ocean on Ceres may have likely froze over time. Remnants of this ocean may still be present beneath a large impact crater on Ceres. The presence of salts may have preserved the liquid as a brine despite cold temperatures on the planet. Between 2011 and 2018, NASA's Dawn mission embarked on a 4.3 billion mile journey to two of the largest objects in our solar system's main asteroid belt. Ceres is about 592 miles across, 14 times smaller than Pluto. NASA's spacecraft Dawn visited Vesta and Ceres. It became the first spacecraft to orbit two deep space destinations. The new research that has been presented is based on observations made during Dawn's orbit of Ceres between 2015 and 2018. This includes close passes it made of the dwarf planet just 22 miles above the surface towards the end of its mission. During its mission, Dawn was focused on the 57-mile-wide Ocata crater, a 22-million-year-old feature that appeared to showcase bright spots on Ceres. These eye-catching characteristics were discovered to be sodium carbonate, or a compound including oxygen, carbon, and sodium. It is, however, still unclear how those bright spots came to be in the crater. Data gathered from the end of Dawn's mission revealed an extensive and slushy reservoir of brine, or salty liquid, beneath the crater on Ceres. It's 25 miles deep and extends out for hundreds of miles. The first impact that created the crater struck Ceres. It may have allowed the reservoir to deposit bright salts visible in the crater by fracturing the planet's crust. As the fractures reached the salty reservoirs, the brine was able to reach the surface of the crater floor. As the water evaporated, a bright, salty crust remained behind. Brines may still be rising to the surface today, which suggests that the activity on Ceres is not due to melting that may have occurred when the planet was impacted. Dawn's data also indicated that the presence of hydrated chloride salts at the center of the brightest, largest area at the crater's center, called Ceres Facula. This hydrohalate compound is common in marine ice on Earth, but it's the first time hydrohalate has been found outside of our planet. Salts in the crater on Ceres seem to dehydrate quickly on the surface. This dehydration occurs over hundreds of years, but it seems to happen quickly in an astronomical way. Measurements taken by Dawn showed that water was still present on Ceres. This suggests that brine may still be rising to the surface of the crater, and that salty liquid could still exist inside of Ceres. For the large deposit at Ceres Facula, the bulk of the salts were supplied from a slushy area just beneath the surface that was melted by the heat of the impact that formed the crater about 20 million years ago. The impact heat subsided after a few million years. However, the impact also created large fractures that could reach the deep, long-lived reservoir, allowing brine to continue percolating to the surface, suggesting geological activity on Ceres. These conical hills are similar to pingos on Earth, or small mountains made of ice found in the polar regions. Although features like this have also been found on Mars, it's the first time they've been spotted on a dwarf planet. The pingo-like structures and the water that pushes up through fractures in the crater revealed that Ceres actually experienced cryovolcanic activity, or ice volcanoes, which started around 9 million years ago, and the process is likely ongoing on the planet. This kind of cryovolcanic activity has been witnessed on icy moons in the outer solar system, with plumes of material ejecting into space, but it was never expected to occur on dwarf planets or asteroids in the asteroid belt, which are thought to be waterless and inactive. New information about Ceres has changed the theory because it has proven to be rich with water and very active. A survivor from the earliest days of the solar system, Ceres was formed 4.5 billion years ago. It was more than an embryonic planet. It started to form but never finished. Jupiter, the largest planet in our solar system, and the force of its gravity likely stunted Ceres' growth. So around 4 billion years ago, Ceres found its home in the asteroid belt along with all of the other leftovers from the formation of the solar system. The idea that liquid water can remain preserved on dwarf planets and asteroids is an intriguing one for scientists, astronomers, and other researchers. Unlike other icy ocean worlds in our solar system, such as Saturn's moon Enceladus and Jupiter's moon Europa, asteroids and dwarf planets do not experience internal heating. Enceladus and Europa benefit from internal heating, and this occurs when they interact gravitationally with the massive planets that they orbit. Like, comment, share, and subscribe. Thanks for watching the Learning Academy. Let me know what you think about